Hello everyone. Today I will explain my homework 4.2, exercise 4.3. Next, write a three language to control piston with set and reset function, timer and show flow theme together. Next, I will introduce my design and work step by step with my PPT. This page shows the main goals of my homework. There are 4 goals. First, learn how to change and use 3 PLC programming languages: lambda diagram, function block diagram, structure text. Second, use set and reset commands to switch the piston's state. Third, use a till-end timer to control delay, making the piston move better. Fourth, build a flow-theme programmatic circuit to check if the PLC program and the physical model work together correctly. Now let's talk about the piston control rules. First, the trigger condition. The start, single start, and indicator limit switch S0 must work at the same time to start the program. Then, the action process after starting, solar wave Y1 turns on and the piston extends. When the piston touches limit switch S1, the timer waits for 5 seconds. Then solar wave Y2 turns on and the piston retracts. Finally, the reset function when we press reset, both Y1 and Y2 turn off and the system goes back to the first state. This page tells you about the 3 PLC programming languages. First, lambda diagram. It's a picture style. Like drawing relay circuits, it's good for electric engineers. Second, function block diagram, FBD. It uses small models to build logical. It's easy to see and works well. Third, structured text. It's like high-level languages. It's good for complex logical and calculations. This page explains key commands. Set makes the output stay true on until we use set. Reset makes the output stay false off until we use set. Till-end timer starts timing when the input works. When the time reaches the set value, the output becomes true. Also, solar wavers and piston. Y1 on to piston extrudes. Y2 on to piston retractors. Y1 and Y2 can't be on at the same time to avoid problems. This page is the I or O address table. To keep the 3 languages logical the same and avoid mistakes, I gave fixed address to all inputs and outputs. For example, the start bottom start is %IX0Y0. The indicator limit switch S0 is %IX0Y1. The extends solar wave Y1 is percent QX0.0 and the timer 1 is set to 5 seconds. This table is the base of programming. All three languages use the same address. This is the ladder diagram program. I divided it into 4 ports. Port 1, network 1, is start up logical. When start and S0 work together, Y1 turns on and Y2 turns off. The piston extends. Network 2 starts the timer when S1 limit switch for extend piston closed. Timer 1 starts its waits for 5 seconds. Port 3 switches after delay. When the timer finish, Y1 turns off and Y2 turns on. The piston retracts. Port 4 is reset logical. When reset works, all output and the timer go back to the first state. Reset has the highest priority and can stop the action anytime. This is the function block diagram program. I use AND block, SR flip-flops, and TLN timer. First, the AND block checks if start and S0 work together. Then it sets a single to SR1 flip-flop, so Y1 turns on. When the piston extends to the end, S1 works and Y1 is on. TLN1 timer starts. After 5 seconds, the timer sets a single to SR2 flip to flop, so Y2 turns on and SR1 turns off, Y1 off. The reset single resets all flip to flops and the timer. SR flip-flops keep Y1 and Y2's states interlock till N1 waits 5 seconds between piston extended and the piston retracted. This is the structured text paragraph. I split the code into 4 parts. They have the same logical and ladder diagram and function block diagram. Part 1 is startup logical. It checks if start and S0 work, then controls Y1 and Y2. Part 2 starts the timer. Only when S1 and Y1 work together, the timer starts. This stops wrong taggers. Part 3 switches after delay. When the timer finishes, Y1 and Y2 change state. Part 4 is reset logical. When reset works, all output and the timer go back. Structured text is clear and good for complex rules. This page shows the float theme phonetic circuit parts. The circuit has 4 key parts. First, air supply. It compresses the air with pressure value, giving stable air pressure. Second, actuators is a double-acting cylinder. It controls the piston's extension and retraction directly. Third, control element 2 5 by 2-way soldered wheels, corresponding to Y1 and Y2. They control airflow direction, force, detention elements to mechanical limit switches, corresponding to S0 and S1. They check the piston position and set signals to PLC. This circuit is the base for linking with PLC. Hardware and software signals work together to control the piston automatically. Let's look. With this simulation, we can see the piston movement, solar wheels on or off state, and the timer line. We can check if the program works without real hardware. This is the summary of my homework. First, completion. I successfully used 3 languages: LD, FBD, ST to control the piston, set or reset, and the timer delay work well. Second, logical consistency. The chronological of 3 languages is the same, only their forms are different. Graphical, model, and texture. Third, simulation value. Floater theme is easy to see. It checks if PLC program and photomatic system work together. It avoids a problem when testing real hardware. Fourth, key points. The interlock of Y1 and Y2 and the good setting of the timer's trigger condition are crucial. They stop wrong actions and equipment damage. This is all my homework. Thanks for listening. Goodbye.